You know, you guys can add a double major in math. It's not too late. Well, we'll work on it. You guys excited? You guys psyched? All right. So we're going to start by talking about linear equations. How do you solve linear equations? What is a linear equation? So how do we solve them, and how can we visualize them using a graph? All right. And so let me get straight into it. So I have to deny my more mathematical urges in here and just work examples often. I mean, every so often I'll give you a proper definition, right? But many times the right thing to do in here is to show you examples. And so we're gonna do that. And then as the opportunity presents itself, I'll throw in definitions, yeah? So example 1. Solve 3x minus 2 is equal to 4x plus 7. How do we solve? This is an example of a linear equation. How do we solve this? What's your strategy? Yep. Get everything on the same side. Okay, so I think what you're telling me is I should try to maybe subtract 3x from both sides, right? And that will get me what? Minus 2 is equal to x plus 7, right? So I subtract 3x from both sides, and then what can I do? That 7's annoying, isn't it? So I subtract 7 from both sides then, right? So minus 7 here, minus 7 there. That gives you minus 9 is equal to x, which for reasons I don't fully understand, I just feel like I have to write this like this. I just, I think it's mostly because I read left to right. So x equals minus 9. There you go. That's the solution, right? What is the solution to an equation? It's a number that when you put it into the equation, it works, right? Shall we do another example? How about 2x plus 3 equals to 2x minus 2? Can we solve this equation? How should we do it? What do you want to do? Let me summarize what we did in the last example, right? Well, what did we do in this last example? Our general strategy was to isolate x, right? That's pretty much it. To solve an equation, you want to isolate x on its lonesome, and then hopefully you solved it, right? Now what happens here though? What happens? Yeah? You can't do it? What happens when we try? We get 0. So like I try to subtract 2x from this side. You can't just subtract it from one side, right? To be fair, you have to do the same thing to both sides of the equation, right? And so, oh no, this gives us 3 equals to minus 2. To quote my community college professor, this dog will not hunt. Yeah, so this is not allowed. No. Right? So if you do perfectly logical arithmetic to a given equation, right, and you reach an absurdity, what does that mean? That means that the original equation is absurd, that there is no solution, right? So here the solution is, solution. Let me say it this way. The solution set is the empty set. which we also write as this, so AKA no solution. So sometimes we ask, like, what's the solution set to a problem? Sometimes we ask for the solution. What's the solution set for example 1? It's very silly. Solution set here is just it's called a singleton. It's a set which just contains one number. This becomes more interesting when there's more than one solution, yeah?
Is that how you want us to write it on the test?
It depends on the instructions. So if the question, if I just say solve the problem, I'm perfectly content with you to write x equals to -9. If I say find the solution set to the problem, then I want a set as my answer, right? What's more important here is when I ask you for interval notation, you use interval notation. But that's not today, so we'll leave that, okay, for later. Example 3. What if we had 3x minus 1 is equal to 3x minus 1? Yeah? Just keep it as is? Yeah, I mean, what happens here? If we subtract, I mean, basically you can cancel the 3x from both sides, and we just subtract 3x from this side, right? Subtract 3x from this side, add 1 to this side, and add 1 to that side. What happens? 0 equals 0. Is this true? Yeah, it's true. So here's the logic, guys. As we either add things to both sides of the equation, right? Or we multiply an equation by a non-zero number, we're not changing the solution set, right? So the equation that we get from manipulating it is an equivalent equation in the sense that it has the same solution set. What's the solution set to the equation 0 equals to 0? What x satisfy that equation? All of them, right? It has nothing to do with x. So the solution set here is absolutely everything. So solution set is actually minus infinity to infinity. Oh man, I was just a second ago saying I'm going to try to avoid interval notation. I spoke too soon. There it is. This is the interval from minus infinity to infinity. Another symbol that I use for this is this funny looking r. R. So that is the real numbers, set of real numbers. It's the whole number line, all right? Any questions? So these 3 examples I've showed you, they're really quite different, aren't they? The first one had a unique solution. The second one had no solution. The third one, everything was a solution. How can we understand that this is happening? Well, I think the way to understand it is to talk about graphing. So let's talk about graphing. Lines. Let's talk about how to graph a line. Okay, so what's a good strategy? How about this? If we have y equals mx plus b, what is this? This is the equation of a line, right? And what is the meaning of m and b? Do you guys remember? Yeah, m is the slope, and b is the y-intercept, right? So the slope is going to be like the change in y divided by the change in x, which specifically would be something like y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are on the line. Let's see here. So let's look at an example of this, yeah? So find line, find equation of line through, let's say, 1, 8 and minus 1, 4. How do you find the equation of a line through 2 points? Well, we need to figure out the slope, right? And the y-intercept is one way to do it. Let's see here. So, what's my slope? So I'm going to think about this as y2 minus y1 over x2 minus x1. I need to decide which point is 1 and which point is 2. Which way do you want? Which way do you want to, guys? Golly. Which one is 2? Which one's 1? Which is the first point and which is the second point? I mean, you got 2 choices. The answer is it doesn't matter. I mean, whichever way you go, as long as you're consistent, it's okay. So let's say that this is the first one just for the sake of making a choice. And let's think of this as the second one. Again, it doesn't matter which, you got to make choice. So y2 is 4, y1, 8, x2 is minus 1, and x1 was 1. So 4 minus 8 is what? Minus negative 4 over negative 2, so that the negatives cancel, and we're left with 2. Well, that's nice. I just made these points up, so the fact that we got an integer slope is actually kind of awesome. All right, I bet b won't be nice. Okay, so what do we know? We figured out that y is equal to 2x plus b, right? But we don't know what b is yet. How do we figure out what b is? Use a point, yeah? So we know 1, 8 is on the graph, right? So if I look at the point 1, 8, that tells me 8 is equal to 2 times 1 plus b, right? So what is b then? I heard a 6. Okay, so you got 8 minus 2 is equal to b, which makes, yeah, b is equal to 6. All right, good job. So we figured out what the equation of the line is, right? So therefore, y is equal to 2x plus 6. So that's how we can find the equation of a line from 2 points. Now, there is an easier way. So I should mention this while we're talking about this. Let me mention to you. Actually, before I do that, let me check my time. I don't want to hurry. Oh, we're okay. So this right here was the so-called slope-intercept form of the line. There are a few other competing formulas. That's slope-intercept. There's also point slope. What's point slope? The point slope formula. With slope m and point, say x1, x2, y2, x1, y1 is y is equal to m times x, excuse me, I don't need to write it, my bad. It's equal to y1 plus m times x minus x1. This is a nicer formula to write down the equation of a line. Yes? Yeah, x. This is x1 and y1. Sorry, is it in the glare? Yeah, there's like a, oh, we've lost the, I don't know. So, I wish they would, yeah, see it's kind of broken. So this is another way to look at the equation of a line. Note there's no y-intercept here, right? But we can apply this formula to find that equation in a slightly easier way. Let me show you what I mean. So we calculated the slope as 2, right? So we could go directly from here to the next step, which would be like use x1, y1 equals to 1, 8, right? And then my equation would be what? Y is equal to 8 plus 2 times x minus 1. I don't have to solve for b. I can just write down the formula, just like that. So if you know about point slope, it makes your life much easier. In terms of you don't have to run through the math of figuring out the b. You can just write down the formula, and then how do you simplify it? If you want to go back to the point slope form, what do? We just multiply this out, right? We get what? Y equals 8 plus 2x minus 2, which gives us y equals 2x plus 6, right? All, the good news is math is not postmodern, right? There's not like different truths. It's not a product of your life experiences or your, whatever. Like math is math. There is an answer. There's a correct answer. It is what it is. Math is funny this way. So like if you work a problem 2 different ways, you just get the same answer, yeah? And we did. Okay, so there's just a quick crash course in how to find the equation for a line given some data. What does that line actually look like? If we were to graph it, how do we do that? So the easiest way to graph a line, right? The easiest way to graph a line is simply this. Get a ruler and play connect the dots. See, because we were given 2 points, right? 1, 8 and minus 1, 4. Where are those? 1, 8 maybe is like here, right? And if that's 1, 8, what was the other one? Minus 1, 4. So minus 1, 4, so that's kind of like halfway up, something like here. And then you just got to connect the dots, right? So you need a ruler. So do I have a ruler? Oh, yeah, there's one. I'm pretty sure that's what this is for. I can't figure out what else it's for. There we go. Line. So it's nice to have a ruler if you have a question about graphing on a test or something. Stay over there. And so there you go. So what's this point right here? This point right here is 6, right? And this is y equals to 2x plus 6. This is how we graph a line. Yeah? So I think students are perfectly capable of this. I want all of you to get full credit if I ask you to graph a line on the test 1, right? You're going to nail this one to the wall, right? So ways students find to get this wrong is like they just connect the dots. Like the line does not extend past the dots. That's always bad. Because the line goes on and on, right? It extends forever. So there's that. That's the main error. And then the other error is like maybe you haven't understood which one's x and which one's y in the graphing. So you got to pin that down. If you're uncertain about that, you got to fix that, figure that out. The first one is the x, the second one's the y, right? That's it. Okay, so now that we've done this, let's go back to our first 3 equations. See, because each one of those we can understand in terms of graphing. Let's do it. Example 1. So what is this? Let's look at it in terms of graphing. So in terms of graphing, if we think of this as y, and we think of this also as y, what are we looking for? We've got y equals, 3x minus 2. And we've got y is equal to 4x plus 7. Right? Think about that. Each one of those is what? Each one of those is separately a line, right? So you can graph both of them. And let's do that. So if I graph the line corresponding to the left, I've got 3x minus 2. So, roughly speaking, it's got a y-intercept of minus 2. It's got a slope of 3. So it's kind of something sort of like this. That's probably not exactly right, but I'm just guesstimating. The other one's y equals, so that's y equals 3x minus 2. I'll do in black. All right? And the other equation, y equals 4x plus 7, it's got a y-intercept of 7, yeah? So that's like up here somewhere, I don't know. And it's got a slope of 4, so it's steeper. It's even steeper than the other line. So this is not a, a totally accurate picture. I'm just trying to give you a sense of it, yeah? So these graphs are, you might call them schematic or something, I don't know. But the point is, if you have two lines, right? And if those two lines have different slope, there's going to be some place where they cross. And that place where they cross is where both equations are true. See that right there? That happens where? It happens at minus 9. So minus 9 is the place where these two lines meet. So when you're looking at an equation like this, one way you can think about it is you can think about one side as the graph of one line, the other side is the graph of another line, and where they meet is the intersection point. All right? Now, what happens with example 2? See, in example 2, you've got 2x plus 3, and you've got 2x minus 2. So I'll do the 2x plus 3 in black. And the 2x minus 2 I'll do over here in red. Sorry, it's getting kind of busy. Poor planning on my part, right? So look at that graph. They're parallel lines, right? They never cross. That's why the solution set here is empty. There's no place where both equations match up. I shouldn't say, well, there's no place where both expressions match up in this case. All right. And then 3, what happened in 3? 3 is exceedingly silly. 3 is exceedingly silly because the graph here is what? You've got 3x minus 1, right? So it's got a y-intercept of minus 1. It's got a slope of 3. There's your 3x minus 1. Right? And what's the graph of the other side? It's the same stupid thing, right? 3x minus 1. So yeah, and so where do these two lines intersect? Everywhere, right? They're the same line. Every point is on both lines, which is why the solution set was everything. All right? So that's a way I can understand when I have a system, when I have one equation and one unknown, why I get these 3 different cases. You can actually look at it in terms of a system of equations, right? What's a system of equations? So I probably should do some more examples in here with like uglier numbers and things. We'll get to that next time. I just want to throw out here for you what a system of 2 equations and 2 unknowns looks like. So it's basically something like this. You've got ax plus by equals to c, and dx plus ey equals to, I don't know, another letter here, f. This is what we mean by 2 equations and 2 unknowns. So the unknowns here are x and y, right? But the interesting thing is you can kind of already anticipate what's the story going to be here. If we solve 2 equations and 2 unknowns, what kind of solutions are we going to get? By essentially the conversation we just had about these 3 examples, we're going to get either a unique solution, no solution, or infinitely many, depending on when you take these equations, right, and you solve for y, you're either going to you get a graph of both of these. When you look at the graph, they're a line, right? Probably, right? So you can get a line from the first equation, you get a line from the second equation. If those 2 lines have the same slope, but not the same y-intercept, there's no solution. If the two lines have different slopes, they intersect at one point. All right? So the next order of business in here is to learn how to solve systems like this, yeah? How are we going to do that? Let's see here. So like example 5. I think we probably have time for just one. Yeah. I'll do a really simple one. If I have x plus y equals to 8, and if I have x minus y equals to 2, the simplest way to solve these kinds of equations is to do what's called elimination. And so you can actually add equations. Check this out. So I take the two equations, and I add them. What happens? What's y minus y? 0. So what do we get? We get 2x equals to 10. We have isolated x, almost. Divide by 2, right? X equals to what? X equals to 5. Right? And what's y? 3. How'd you guys get that? And seeing other math instructors? Are you guys cheating on me? Let's see here. Oh, I'm sorry, that was kind of cringy. Let's see here. X plus y equals to 8. So plug the 5 in, right? 5 plus y equals to 8. So y is equal to, I'll get out of the way here in a second, 8 minus 5, which is 3. So therefore y equals to 3. Why is this true graphically? The first equation is y equals to 8 minus x. The second equation is y is equal to x minus 2. You graph those. The one's intercept is minus 2. The other's intercept is 8. Got slope minus 1. This point where they intersect is 5, 3. That's what's going on. Two lines with different slope. They intersect at one point. The point where they intersect corresponds to the solution to this system. Hey, listen, I'm sorry I was a little bit rushed at the end. We'll do this a lot more next time. And we'll also look at 3 equations and 3 unknowns. So, nice to meet you all. Have a good week. I hope you enjoy your other classes.
Me too.
I always, so it's this button here.